Good morning, Core Math 2 students. This is your Week 6 Lesson 2, and it is all about the secant intersections outside a circle. So yesterday we talked about chords of a circle. Today we're going to talk about secant lines. So what is a secant line? It is a line that cuts through the curve of a circle in two places. So it's essentially as if a chord were turned into a line. So here's some important information. When two secant lines intersect outside a circle, the products of their segments are equal, but it's a little different than with the chords. So here is the equation that we need. So in the picture, segment PA, so this short segment here, is going to get multiplied by P times B. So it's the portion of the secant times the overall length. And that's equal to P times C, that same short measurement, times P times D, the overall measurement. Okay, so let's take a look at some examples. Here in example 1, from P to the circle is 8, and then there's another 11 units. From P to the circle is 4 here, and then from there on it's another X units. So this is not drawn to scale, just like before. So if I set up the multiplication for this top piece, it would be the measurement X times the overall measurement. So I need to add these two together. 8 plus 11 is 19. So that's the product for that top secant line. For the bottom secant line then, it's equal to the first segment from P to the circle, which is 4, times, and then I need the overall segment length. Well, we don't have X, so this expression then is 4 plus X, or X plus 4, in whichever order you like. Okay, so if we do a little simplifying, 8 times 19 is 152, and that's equal to 4 times 4 plus X. Well, that's in parentheses, so if we want to proceed solving, we need to start by dividing by 4 to get rid of that off the front. So divide by 4 on both sides. 152 divided by 4 is 38, and that's equal to 4 plus X. So we freed that up so we can finish solving for X by subtracting 4. This tells me that the length of X is 34 units. One more example before I turn you loose. Example 2, from P to the circle is 6, and then another 8 units. From P to the circle down here is 2 units, and then another X units. Once again, these are not drawn to scale. So if we set this up using our formula, using our product, that first top secant would start with the 6 times the overall distance. 6 plus 8 is 14 units. And that will be equal to the bottom secant pieces. So we've got 2 units, and then this is getting multiplied by the overall length. So to write that out, that would be 2 plus X, or X plus 2. If we do a little simplifying then, 6 times 14 is 84, and that's equal to 2 times the 2 plus X. And if we want to start solving this down, let's start by dividing by 2 to get rid of that from the right side. Be sure to divide by 2 on the left. 84 divided by 2 is 42, and that's equal to 2 plus X. So if we finish solving for X by subtracting, that means that X is 40 units long. So that is the scoop on secant intersections outside a circle. Head on over to Delta Math, and good luck out there.